one thing that I ran across, there's a few little libraries that are so simple, and yet when you come across them, you're like, oh yes, this is so cool. One of those that I go on and on about is Unsync, how that unifies all the different APIs that do asynchronous programming, like async IO, threaded stuff, multiprocessing stuff, and whatnot, right? So this is one I think that kind of is like that. It's not about unification, but it's about solving a problem in a way that's kind of transparent to the user, but is really, really awesome because it just adds some nice durability to your code. So there's different levels of like exception handling if you look at it, right? So if you look at code, there's probably like the beginner level that has no try except blocks anywhere in the code. It's just like, I don't know what you call it. Is that optimistic programming? Like, I don't need to do error handling. It's going to be fine. Everything's fine. This is fine. That's one way. The next level would be to say, okay, I'm going to have some exception handling. I'm going to do a try, do a bunch of stuff, except handle the error, right? That's good. And maybe you're catching different errors. Like maybe that's another level. I don't know what I'm making these levels up a little bit. But even if you are catching an error, something could have gone terribly, terribly wrong and corrupted your data along the way. So there's like durable error handling, and it isn't technically crashing at the moment error handling, right? So the durable error handling, I don't think a lot of people think about nearly as much. So simple example is what you would maybe use a transaction for in a database is like, I'm going to transfer money from this account to that account. But what happens if the transfer to the second account fails? I want to make sure I don't actually take the money from the first account, right? Yeah. Or I want to write some piece of data to a file. So I'm going to open the file. I'm going to make sure there's a try except. I'm going to put it in a with block so the file pointer gets closed. Everything's going to be good. I'm going to make one change and another change and then a third change, like write these three things to the file. What if the exception happens after the second line? You've half written to the file. Now what?
I don't know.
That's bad, right? So there's all these ways in which, like, you still have a try except, you still catch it, you still close the file pointer. It doesn't matter. It's corrupted, right? So there's like this another level of error handling of like kind of treating memory and files and whatnot as transactional type of things, right? If there's an error, they just go back the way they were. And so this thing that this long-winded introduction is about is called Safer. So a Safer file writer. And it's this cool, simple little thing. Instead of saying with open file name as file pointer, you say with safer.open file name as file pointer. And then otherwise, all your code is identical.
Okay.
But here's what it actually does. So as you write to the file pointer, it's writing to a temporary file behind the scenes. And then if, when you exit a with block, the exit, the dunder exit, takes whether or not there was an error on the way out the door. So as you exit the with block, am I leaving because of crash or am I leaving because everything is cool and we're done? So it uses that information to either throw away the temp file or move the temp file over top the thing you thought you were writing on.
Oh.
Isn't that cool? So if there's an exception in your with block, it still closes up the file pointer and everything, but your data is unchanged. It's kind of like a transaction with a auto rollback for files.
That's pretty
Isn't that cool? And it's like 28 lines of code that does that little bit.
Yeah. Is it any idea what the time hit is? It's got to be a little bit.
It's pretty small because it just uses shutil to replace the file. Like it writes to the file just as you would write to the file. And then at the very end, it goes, move this file to this destination and overwrite. So it basically adds a file move, which in an SSD is like nothing, right? It doesn't matter how big it is. It probably just like updates the table in the drive, whatever that means.
Yeah.
Isn't that cool?
That is very cool. I like it.
So it seems so easy to use. It looks like something that might be worth looking at. So I'm linking to a couple of things. I'm linking to an article that introduces this. And in the beginning, apparently there was like some edge case where something wasn't working quite right. If you passed like an integer representing a file handle or something funky like that, it didn't deal with that right. So there's another like a updated article that doesn't have all the motivation, but then talks about this fix. And there's also a GitHub repo, and you can just pip install it. So all those things are good. And the final, in this section, I'm linking to the actual 28 lines of code. Do you have that open? Yeah, click on that really quick, because I want to talk about a couple of really interesting patterns here. Like, if you wanted to study 28 lines of code that and brought together a bunch of interesting ideas, like, whoa, this is pretty crazy. So it has a generator expression on an infinite sequence of numbers to find the temporary file, which is pretty interesting, because it just says, I'm going to call it .1, .2, .3, and in case those exist, we're just going to go through all of them until one doesn't. Isn't this crazy? So that's pretty fun. And it uses shutil to copy the file over, which is pretty cool. It uses yield to automatically return the inner file pointer. So when you say with thing as whatever, even though you said safer.open, it actually yields out the underlying file pointer that came from open. There's just a bunch of different layers of, oh, that's interesting. Well, that's neat. Yeah. Anyway, I think this is really clever, and it seems like a cool little library. It's the reason I think it would probably be useful, and I'm not going to give you a big hit. It's like, this is literally it. You can see it's creating the temp file. It writes to the temp file, and then it uses os.rename the temp file to the actual thing. So not a whole lot of magic going on, but really quite useful, I think.
Not a lot of code either.
Yeah, isn't that crazy?
Just
I love it.
Cool.
Useful. Gives you that sort of durable error handling, almost like transactional files, and yet super simple. Very good. All right.
Uses unit test as its test runner, though.
Oh my God. Well, all right. I retract all of my endorsements of this thing. Thank you for watching this segment of the Python Bytes podcast. This video was made during the recording of the full episode. Visit pythonbytes.fm and get the whole story. Subscribe to the podcast and get the entire episode delivered to your phone. Please support our work by taking one of the courses at pythonbytes.fm/courses or learning PyTest with Brian's book at pythonbytes.fm/PyTest. Finally, visit our sponsor shown on the screen here. Visit the link on the screen and get the special offer for Python Bytes and YouTube listeners. Thanks, and have a great rest of your day.